Hello everyone. Today in this video we will be learning on some solved questions which are exam based, मतलब जो past papers में throughout different universities पहले आ चुके हैं. So those are very important questions. So let's see how we can simplify and solve them. So first question is here: if u is equal to log of x cube plus y cube plus z cube minus 3x square z. So we have to prove it. This whole bracket square del by del x plus del by del y plus del by del z bracket square into u is equal to ये जो दिया है राइट हैंड साइड में होना चाहिए. So सबसे पहले तो गिवन फंक्शन हमें जो दिया है उसको as it is we will write it. It's in terms of x, y, z. U is a function of x, y and z. As you see this, there are different terms which are here in terms of x, y, z. So then next thing we will be differentiating this given function with respect to x, y and z. सारे rules हमें याद होने चाहिए कि if we are differentiating with respect to x, how we will be treating y and z will be constant. So y will be constant here. So here the given function was in terms of log. So as you see here, this is a log. Differentiation of log क्या होता है? Differentiation of log x तो हमें पता है इसका differentiation होता है 1 by x. जो differentiation में होता है उसी तरह यहाँ पे भी partial differentiation में भी उसका partial differentiation log function का 1 by x ही होगा. तो हम जब इसका differentiation करेंगे with respect to x और y या z के साथ जब with respect to हम differentiate करेंगे तो इसका differentiation 1 upon this whole bracket will come over here. So जो मैंने इसमें आगे की step में किया है. So here if I am differentiating this given function u with respect to x, so the partial differentiation is 1 upon x. और उसके बाद में जो ये फंक्शन है पूरा उसका डिफरेंशिएशन मैंने इस ब्रैकेट में लिख दिया है विथ रिस्पेक्ट टू x. सो अब इफ़ आई डिफरेंशिएट दिस फंक्शन विथ रिस्पेक्ट टू x, सो दिस टर्म डेफिनेटली आई हैव टू डिफरेंशिएट बिकॉज इट्स x टर्म, सो इट विल बी 3x स्क्वायर. y will be constant, so this will be become 0. Similarly z is a dependent variable, so here what I will get here, this will also become like a 0. Here it will become minus 3yz, x का derivative 1 हो जाएगा and minus 3yz I will get it. So denominator here will be as it is. So similarly with respect to y we will be differentiating u here and we will keep log u, that differentiation will be 1 upon u which I written here, and we will be multiplying differentiation of this whole thing with respect to y, so that's we have to multiply it. So since we are differentiating with respect to y, this derivation will be 3y square and minus 3xz because z's differentiation will be 1. So that's how we will be getting. Similarly we can differentiate with respect to z also. So there I will get del u by del z, since it's a log function 1 upon z, and differentiation of this given function with respect to z. Since differentiating with respect to z, x and y, this will become constant and that will be differentiation will be 0. इसका z cube का हो जाएगा 3z square and this last term will be minus 3xy क्योंकि z का differentiation x हो जाएगा because we are differentiating with respect to x. Now we will be adding all these terms. What we found, del u by del x, del u by del y plus del u by del z, we will be adding it because we have to prove that. So whatever we found in the previous slides, the value of del u by del x, these all three values I have kept it over here separated by addition sign. So if you look at carefully, everywhere the denominator is same, so we can directly add these numerators. And if you notice here, every term in the numerator has 3 here. So directly what we can do it for simplification, 3 we can take it out common from all the terms in the numerator, and I can whatever is left over उसको एक bracket में डाल देंगे. तो x square plus y square plus z square ये हो जाएगा numerator minus yz minus xz minus xy. सो यहाँ पे हमने न्यूमरेटर को तो सिंप्लीफाई कर लिया, डिनोमिनेटर को वी हैव टू स्टिल सिंप्लीफाई इट. इफ यू लुक हियर, it's given in the form of cube. So this looks very similar to expansion formula which you might have learned in school, so which is in the cube form. So I have to remind you or to revise you, I have put it over here. So this is the expansion formula which is in terms of cubes. So a cube plus b cube plus c cube minus 3ab. So this is the whole formula which we have to apply here, because our denominator, if you look carefully, this is something like here, which is exactly same like how the expansion formula looks like. So we can use that for this to simplify the denominator. So what I can write in one bracket, I will write addition of this one, and in the second bracket I will write in this format, like how my formula, expansion formula is telling. So that's the way I have simplified the denominator. Right in one bracket x equals y plus z, and in the other bracket I have taken the square and their relative subtraction. So now if you look here, this bracket which is in the numerator, it's exactly same like here if you see in the denominator. So we can cancel it, and whatever is left is just this 3 upon x plus y plus z. So now if you look at carefully to the left hand side, which they ask us to prove it here, this whole bracket has been given del upon del x plus del by del y plus del by del z bracket square, and u is nothing but the given function which we have to multiply with it. If you look here, u's power is 1, so and here the bracket power has 2, so directly we cannot multiply them because they have different powers. So what we can do is, since this is a square, so I will write it 2 times like as expansion, and this u I am multiplying you with u, so I have written it as it is. So that way we are keeping power of each of these term as a 1, so we can multiply. Now this u I can multiply here in this bracket directly, so I will get by multiplying this u with this bracket. So here del u by del x I will get del u by del y and del u by del z, which I wrote it here in this bracket. This first bracket will be as it is here. Now if you look here, what this value is which we found here, this is nothing but this bracket which we are looking for. This whole bracket, this value we already found it here. So what we can do is we can directly substitute this value over here, so that we can simplify it further. So what I have done, that substitution I have done for the second bracket, I have kept 3 upon x plus y plus z. So this is this would be my next step. So I have written here so that I can expand it, or I can multiply these 2 brackets over here. So after this is simple expansion, like how we do it, 2 brackets like a plus b, and if you have to like c, like simple expansion, how we do it, the same way I have done it here. With del u by del x I multiplied with this one, del by del y I multiplied with this one, and then del by del z I have multiplied with this one. So this is what nothing but I have done it here. Now since we have to find the differentiation, partial differentiation of this 1 upon x plus y plus z with respect to x, with respect to y, and with respect to z. So if you look here, it looks something like 1 upon x. This whole function we can treat it as a 1 upon x, and if you remember how we find the differentiation of 1 upon x, it's a minus 1 by x square. Same thing is here also in partial differentiation also. If you consider this function as a 1 by x, its differentiation will be minus 1 upon this whole term, x plus y plus z bracket square, exactly same like how we do with 1 by x. So for this whole bracket with respect to x, when we will be doing partial differentiation, it will be minus 1 upon this bracket, minus 1 upon this whole bracket. Now similarly with respect to y, if I am differentiating, this will be minus 1 upon this whole bracket. Again with respect to z, I am differentiating, it will be minus 1 upon this whole bracket. So now all denominator is common, so I can simply go ahead and add the numerator, and then I will get it is minus 3 upon x plus y plus z bracket square. So if I will just multiply it, then I will get my answer as minus 9 upon x plus y plus z bracket square. That's nothing but our RHS which they ask us to prove it. So simply what we have done it is the given function. I will just go quickly through all the steps. Given function we have considered as a u, that was given function. Then what we did it, we with respect to x, with respect to y and with respect to z, partially we differentiated it. We took the addition, we simplified the numerator by taking out common. Then we used the indices expansion formula to simplify the denominator, and after that we try to simplify it more further by taking the partial differentiation. Those are the few steps which we took it. Those are pretty straightforward. Only thing is indice expansion formula, we have to remember it or revise it. Then other things will be pretty straightforward. Let's take a small break over here. Meantime, you can revise the concept. In the next video, we will be discussing this more in detail.